Okay, so we're talking about the Poisson distribution, and the Poisson, we say that it is a very common distribution. It is used to find probabilities involving a success or a failure in a given time interval. Okay, it is also used to find the probability of the number of occurrences of events per unit time. So in the Poisson distribution, we're still looking at having two options, that is a success or a failure, but in a given time interval. Okay, so the Poisson will always have the average number of outcomes per unit time, which is denoted by lambda. So that is the Greek letter. Okay, so that would denote the average number of outcomes per unit time. So let's get the formula for finding probability. Probability that x is equals to small x is just lambda raised to the power x exponential to the power minus lambda, okay, over x factorial. So that exclamation mark, in mathematics we call it factorial. Okay, so the x is the number of successes in a segment, and lambda, of course, is the average number of outcomes per time, and e is the exponential base. It's there on our calculators. So e is usually denoted ex on a scientific calculator. So just press this function. The next value that you put is a power, so you don't need to raise the e to another power. Okay, so how do we find the expected value when a random variable follows the Poisson distribution? The expected value of x is just lambda. The variance of x is also just lambda, and the standard deviation is the square root of lambda. Okay, so we have that example. Birth in a hospital occur randomly on an average of 1.8 births per hour. What is the probability of observing 4 births in an hour? So our average there is 1.8. Therefore, lambda will be 1.8. Then from the question, we find our x. What is the probability of observing 4 births in an hour? So our x is 4. So to find that probability, we use our formula, which is just lambda to the power x e to the power minus lambda over x factorial. So the factorial function is also there on your calculators. When we replace, we have 1.8 to the power what? 4 e to the power minus 1.8 over 4 factorial. So punch that on your calculator, and the answer that you're going to find is 0.0723. In the second question of this example, we need to find the expected value, which is just lambda, and it's 1.8. The standard deviation is just the square root of lambda. It's the square root of 1.8, and our answer is 1.342. Okay, so from our handout, please do the second example. I'm sure you should be able to get the answer. Okay, so thank you so much. We're going to end here.